Srinagar, and today the mathematics faculty has conducted a mathematics exhibition where we will see different projects and models of different students from our school. Everyone is looking energetic and enthusiastic, so let's jump right into it. So we are currently standing outside class 9th A, and we have got some really interesting projects to see. So let's firstly talk. Can you please explain what this model is about?
So we have a transversal between two lines L and M here. So we know that the theorem is when the sum of two co-interior angles is 180 degrees, so the lines are parallel. When we reduce the sum of these two lines, suppose this is 110 degree and this is 30 degree, this becomes 140 degree only. So these two lines are not parallel then. There must be a sum of 180 degree to make these lines parallel. So this is the practical application of that theorem.
Wow, amazing. Now, can you please explain what this model is?
Good morning. This is the model of angles made by a transversal. If we put this pen on this, then this will bring. These two are vertically opposite angles. These are corresponding angles. These are alternate interior angles. And these are alternate exterior angles. Same case is here. Vertically opposite angles, alternate interior angles, alternate exterior angles, and corresponding angles.
Yeah, that was amazing. Now, can you showcase your project?
Yeah, surely. Good morning. My name is Mohsen Muzair. So I've created a project with squares from 1 to 10. Here we have squares from 1 to 10. When I just rotate this thing, you can just get the perfect square. That is 1 square is 1. And you can also find the square roots if you go from right to left. For example, the square root of 1 is 1 and the square root of 4 is 2. Also, it's a really interesting project as you can use it in PhD. That's Pythagoras Theorem, and it's also used to find the area of a square. So it's used in daily use.
Amazing.
I've also derived the formula for its surface area and its volume here.
Amazing. Amazing. Now, can you please showcase your project?
So this is a project on types of angles. So we have many angles like acute angle, right angle, and many more. So if I move the arrow, for example, we have acute angle which is less than 90 degrees. So if I move the switch like this, it becomes an acute angle. For example, 70 degree. And then we have the same like obtuse angle which is less than 90 degree. So if I move this, it is 140 degree, which becomes an obtuse angle.
Amazing. We are currently standing outside class 9th B, and we have also got some great projects to see here. So let's talk to the first person.
Good morning, everyone. This project is about this project is about the properties of a rectangle that when it rotates, it forms a cylinder. Now I'll show you how to do this. So as you can see that when a circle is rotating, when a rectangle is rotating, it turns into a cylinder. So this is the project we have prepared for the property of a rectangle that it turns into a cylinder.
Hello everyone, I am Usman from class 9B. Today I have prepared a project on the basic properties of circle. So I'll show you how it works. So this is the minor sector and this is the major sector. This is the radius and this is the diameter. This is a chord. This is an arc, and this is an arc, and this is the minor sector, and this is the major segment. Minor segment and major segment. Thank you.
This is Abacus. It is an ancient yet continuing device called Abacus. It was started by Sumerians. It is still used in for Aloha math camps and clubs extra. Below this partition there are 5 non-numbers, and above this there are 5 numbers, and this is ones, tens, 100,000 and extra, and it is still used.
So can you please show us what you have made?
Yeah, sure, I am. Hello ladies and gentlemen, I'm Muqaddas Ishrat from class 9B. So today we have make a model. Like in our day-to-day life, you already wonder that what's the use of math in our day-to-day life. So here's an actual representation of it. So let's take an example. You all know that in our day-to-day life we go around like our surrounding, we find many of the things cool. So now we will be comparing this quantity of my ring with the, take taken a gram of 5 grams and we will compare it so that it could be equal. Now, if you think that, if you know that, let's take another example. We take an example of ring with a 900 grams of the term, so it will not become price. So this is a working model that how in our day-to-day life the mass is being utilized. Thank you.
My name is Hunlan and I have made a model of a theorem of circles, which is angle separated by an arc at the center is double the angle separated by it on the remaining circle. So in this, I have put two protractors. So here I'm going to measure the angle here. It will be, so it's 150 here. So it should be 75 here. So the angle is, so it's exactly 75 here. Not on this, we can rotate this to any angle. Let's say 180. So it's 180 here. So it should be 90 here. So I'm gonna measure it 90. It's exactly 90 here. So by this, the theorem is done. Wow. Now we are standing outside 9th C and let's see what the students have got for us. Can you please explain your model?
Good morning, my name is Kamar Sameer and I have made this working model on the types of polynomials on the basis on terms and on the basis on degrees and terms. On the basis of terms, it represents monomials, binomials, trinomials, and on the basis of degrees, it represents linear degree, quadratic degree, cubic degrees.
Hi, my name is Habib. A pleasant morning to everyone. Me and my friends have made a project of congruency of triangles. So what does congruency mean? Congruency means when two triangles superimpose each other, which means when they have equal sides and they are equal to each other. So we have proved three congruencies of triangles. The first one is RHS rule. The RHS rule stands for right hand side rule, which is equal in right angles. The second one is SAS rule, when there is side angle side, when there are two sides and one angle equal to the other. The third one is SSS rule, when there are three sides equal to of a triangle equal to the other triangle. That's it. Thank you.
My name is Adiba, I'm from 9C, and today I have represented a piece of art, a piece of information, which is totally based upon the history of mathematics. I know obviously you can't trace the origin of mathematics, but rather we can't exactly tell when mathematics was originated, but rather we can help with the help of the culmination and combination of the inscriptions of past various discoveries in mathematics and inventions helped us to deal with the history of mathematics. So basically, the history of mathematical notation includes the commencement, progress and cultural diffusion of mathematical symbols and the conflict of the methods of notation confronted in a notation's move to popularity or Mesopotamians. Then let me introduce to you a very great guy, a great mathematician, a person who is widely known for mathematics in the antiquity. He has contributed widely in physics. He's an astronomer, physicist, and a mathematician too. The great guy is Archimedes. We have studied that in physics as well. We don't need too much about it. And then we have Mr. Euclid. We already know about Euclid, that in 9th class students do well know about Euclid. He has given us the fundamentals of geometry, and you see here the proof of Euclid's elements. Then you have, let me give you an analysis of what Indian mathematics looked like in the ancient age. So I assume that we all know about the Indus Valley civilization. So the ancient civilization of the Indian subcontinent led the foundations of the Indus Valley civilization with regularity of the perfect geometry, not exactly perfect, but the geometric regularity. And it is we have no mathematic records for it, but listen, we say that it is the foundation of the mathematics. Then you have analysis of the early Chinese mathematics, which has demonstrated its unique development compared to the other parts of the world, leading choices to assume the entirely independent development. And these are the tables of numerals and other shapes in the application. I have included some facts. I would like to conclude with the last fact that Hypatia was considered to be the first ever woman mathematician in the history of maths. Thank you so much.
We are currently standing outside 9th D and let's see what the students have got for us. Please explain your project.
This is Pythagoras Theorem working model project. This is the base 13 centimeter. This is the perpendicular and this is the hypotenuse. Base is 13 centimeter, and if we keep the perpendicular as 14 centimeter, we can find the hypotenuse.
Great. Now can you please show us what you have made?
This is the algebraic identity. When you spin the wheel, here comes the identity and then comes the solution. For example, this is an identity and this is the solution. And again, when you spin the wheel, there comes the identity and this is the solution.
Great. Please showcase your project.
Good morning, my name is Ida and this is a simple project on multiplication tables. And suppose if you move it to 13 and you want what is 13 sevens are, the point of intersection is the product you want of the desired number. So 7 13s are 91. Similarly, you can do it for other numbers like 8 13s are 104. Thank you.
Good morning, my name is Said Huzan. I made this project. Using this, we can find the day of any date. Like if I take 15th August 1947, I can find the day of this. I will write this as it is. For the month, we have the month codes. The 8th month is August, so we write instead of 8, we write 3. And for the century code, we have 20th century is 0. We write 0. We write this number as it is. We divide this number by 4 and write here. To find the leap years, how many leap years has passed between these years. Then we find the answer. We get 76. We divide this by 7. We have 7 days in a week. 7 10 are 70. We look at the remainder, it's 6. So it was a Friday, 15th August. Right?
Amazing.
My name is Saskia and I'm from 9D and this model is made by Ihsan. This model depicts algebraic identities. There are two sides, one is the short form side and second is the expanded form side. If we keep one wire on the short form side and second on the expanded form side, and if the answer matches and they are the correct forms of each other, the bulb will glow. And if they are not the correct form, the bulb will not glow. This is how it works.
Amazing. Currently standing outside 9th E, and let's see what the students have got for us. Please explain your project.
I am Tehzeeb and this is my project, and in this it's a coil snake which has spirals and it represents Fibonacci series, which Amana will explain what Fibonacci series actually is.
So hello everyone, my name is Amna Irfan and today I'm going to explain you the model of the Fibonacci sequence. So as you can see, the Fibonacci, it was first discovered by the Italian scientists known as Fibonacci, Picasso and Bonobo. His nickname was Fibonacci and his day is celebrated as November 23rd. So its sequence goes like 0, 1, 1, 2, 3, 5, 8 and so on. So if we make the squares, perfect square of these numbers 0, 1, 1, 0, 1, 1, we can see if we can join the up, starting the up from 1 and going on towards each box, we can obtain a spiral. So these spirals are found in many living natures like flowers, pineapple, snails, snake also, coiled snake also represents the Fibonacci sequence. This Fibonacci sequence, if you take the ratio of it, it's known as the golden ratio. Thank you, have a nice day.
Can you please showcase your project?
So basically this represents a tetrahedron. It has 4 sides and 4 vertices. It is also a chemical structure of many chemical compounds like methane and all the other compounds. And its chemical structure represents the tetrahedron geometry that comes under the mathematics. Thank you.
So we are currently standing outside 9th F and they have some interesting projects to see. Can you please explain what you have made?
This is 3D models. There are the shapes of 3D shapes and there are written the surface area and the volume is written here, and they are all colorful, and it also includes a cuboid, a cube, a cylinder, a sphere and a cone.
Amazing.
This is the representation of perfect square root and perfect cube root. Just like the root of 4 is 2 and the cube of 2 is 8. Similarly, the root of 9 is 2, 3 and the root of 1 is 1.
Amazing. Can you please explain your project?
Yes, sure. It is a tetrahedron. It is also known as triangular pyramid. It has 6 edges and 4 vertices, and all the 4 triangular faces. The edges are equidistant from each other. Vertices are equidistant from each other.
Thank you very much. Can you please explain your project?
So we got a spinning wheel here. We know that square numbers are numbers we get when we multiply integers with itself. And we got these spinning wheel numbers that are the squares of numbers actually. As you can see, the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, the square of 4 is 16, and we even got a model regarding the congruencies of triangles. We have proved triangles congruent here by the SAS congruency rule. We have proved triangles congruent here by the RHS congruency rule, and even we have proved triangles congruent by the SSS congruency rules. And this is all what we have.
Amazing. Can you please explain your project?
Yeah, so this is a model of a protractor. This is a mathematical device used to measure angles. It was invented by Joseph Coudards. And this is a model that represents an initiative that can be used to teach kids the concept of before, between and after. Thank you.
Greetings everybody. Today I represent to you this tetrahedron. This tetrahedron is made up of 4 triangular faces and 6 edges plus 4 vertices. It is also known as a triangular pyramid. As you can see, it is the smallest of all the polyhedrons, and all the vertices are equidistant from each other. And this big tetrahedron is made up of 4 different tetrahedrons with different colors: the blue one, the red one, the orange one, and the white one. Thank you so much.
So we are currently standing outside 9th G, and let's see what the students have made. Can you please explain?
Yes, so I made a chart which explains number systems, which you can see here. Also, I've prepared this kind of a presentation about why we cannot divide by 0, which is one of the most fundamental questions in mathematics and why it is unsolvable. So here I've tried to prove that division by 0 is undefined, not because mathematicians are lazy or something, but because it is undefinable. When we try to solve it, we find that it contradicts something that is most fundamental in mathematics, and therefore it is undefined.
So yeah, it's all about mirror image. So actually mirror image is the reflected duplication of an object or a figure, which actually appears to be identical but is reversed. And if we'll take the x-axis as the line of reflection, we can see that the sign of the ordinate will change. Like in here the coordinates were 3, 2, and here it's 3, -2. And similarly, if we take the line of reflection as y-axis, so the sign of abscissa will change. Like in here we had the coordinates as 3, 2, and here we have -3, 2. So it's all
amazing.
This here I have a working math model of algebraic identities. It's a really fun and easy way to learn algebraic identities. Let me just show you a little demonstration. So if we connect, if we have this algebraic identity x minus y whole square, if we connect it to the right algebraic expression, it will light up. But if we do it to the wrong one, it won't light up. Let's say we have this one. If we connect it to the right one, it should light up. It's a really fun and easy way just to learn algebraic identities.
Nice. Can you please showcase your?
I'm Mohammed Rayan from class 9G. I made a spin wheel model for algebraic identities. Let me show you a demonstration. If you spin this wheel, we know that a plus b whole cube will be equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. This is a correct expanding form of a plus b whole cube. And as you can see that it is a fun and very easy way to learn all these identities.
So we are currently standing outside 9th Edge. We have got a lot of models to see. Let's see what they've got.
So we have made a model of triangles that is explaining the various criteria for congruency, and this is another model that explains the parts of circles. So here we have SSS congruency rule. First, congruence is when two triangles they are of same shape and same size. That's called the congruence. And we have various criteria. This is SSS rule, RHS. So SSS is when three sides of one triangle are similar or of same size to the other triangle. Then we have RHS, when hypotenuse, perpendicular and the base of one triangle is same as that of the other. That is, these triangles, they are congruent by RHS rule. And this is how she'll be explaining about these various parts of circles.
Parts of the circle. As we know, the circle is a collection of the points that has a fixed distance and a fixed point. At a fixed point, it has various parts like radius. There is radius, diameter, chord, minor minor segment, minor sector, major segment and major sector. And as you know that radius, it is a fixed distance and center is a fixed point, as all the circles have a different properties. Thank you.
Choose to make some solid figures including a cone, cube, cuboid, a hemisphere and a cylinder, along with their volume, curved or lateral surface area and total surface area. Starting with cone, its volume, which means the total space it occupies, is 1/3 pi r square h, and its curved surface area, which means the area of its curved surface is its pi r n, and its total surface area is pi r into l plus r. Similarly, for a hemisphere, its volume is 2/3 pi r square, its curved surface area is 2 pi r square, and its total surface area is 3 pi r square. For a cube, its volume is a cube, lateral surface area is 4a cube, 4a square, and surface area is 6a square. And similarly, for these figures, you can see here their volume, their lateral surface area.
Amazing. Can you please showcase your project?
Yes. So basically, this is a rectangular, and a rectangle is a quadrilateral with four right angles. It can also be defined as an equiangular quadrilateral, since all of its sides are equal, or a parallelogram containing right angles. The word rectangle comes from the Latin word rectangulus, which is a combination of rectus, right, and angulus, which means angle. A rectangle is a convex quadrilateral if it follows any one of the following: a parallelogram with at least one right angle, a parallelogram with diagonals of equal length, equiangular quadrilateral with four right angles. The properties of a rectangle are: opposite sides are parallel, opposite sides are equal, angles are equal, diagonals are equal, and diagonals bisect each other. Thank you.
Thank you very much. Can you please showcase your project?
The following project I have made is known as the Cartesian plane. It is made up of two line segments that intersect each other at right angles. The line segment that goes horizontally is known as the x-axis, and the one that goes vertically is known as the y-axis. This leads to the formation of four quadrants: quadrant 1, 2, 3, and 4. The name of these quadrants is dependent upon what quadrant they lie, what place they lie in the Cartesian plane. So, for example, for the first quadrant, it lies in the positive x-axis digits and the positive y-axis digits, meaning it can be depicted as plus and plus. Thank you.
So we are currently standing outside class 9th I, and let's see what they've got for us today.
Good morning, my name is Mohammad Ifam and I am from 9th I. Today I am going to present a chart on volume and surface area. I am going to present the volume and surface area of different types of solid. For example, we can take cone. The formula to calculate the volume of a cone is pi r square h by 3, and the formula to calculate its surface area is pi r by r plus under root h square plus r square. Here h square for the height and radius stands for the and r stands for the radius of the cone. And for example, in cube, these are the S is represented to represent the side of the cone. Here S stands for the side of a cone.
Today I have made this model on algebraic identities. These sides depict the identities of algebra. From the left side is the short form of the identities, and the right side is the extended form of the identities. This is the first identity, and this is the second identity, this is the third identity, and this is the fourth identity, this is the fifth identity, and this is the sixth identity and seventh identity, and this is the last identity of the algebra.
I am Rahim Riaz from class 9th I, and this is the model of a clinometer. A clinometer is used to measure the angle of elevation of any object at the same height. The straw is used to view the top of the object whose angle of elevation is to be found. The angle is measured with the help of the program.
So we are currently standing outside class 10th A, and let's see what the seniors have got for us.
So I have made two programs. One of them has 4 options to choose from. You choose one of these 4 shapes and you give it its dimensions, it will calculate its volume for you. And there's another program that you give it two sides of a right angle triangle and it will calculate the third side. Using that.
Exceptional.
So this is a Clinometer. For example, we take this bottle and let's say we have put it 10 centimeters away at a certain height. We need to calculate this height. So through this we will take a look at the top of this bottle and see the angle. For example, it is 60 degree here. Now we know the distance 10 centimeters and the angle of elevation, it is 60 degrees. So using the trigonometric ratio tan 60, which is perpendicular by base, we can calculate the height, and tan 60 is under root 3, so by multiplying it with the base we can get the height of this figure.
This is a diagonal of a cuboid, so this is a diagonal that is connected from this vertex to the top, and it forms the length, breadth and the height, and this is the formula of the type.
We are currently standing outside class 10th B. Let's see what they've got for us.
As you can see, this is Inclinometer. It's used to measure heights and taller buildings. As Alina will show you with the help of an example.
This is the example of how to measure with the help of a clinometer. As you can see, here's the clinometer and we have to find the height of this house. It's based on the ratio tan theta, which is equal to perpendicular by base. If you know the perpendicular, we can find out the base, or if you know the base, we can find out the perpendicular. We have to find the angle of elevation and then we can find the height of the tower.
We are currently standing outside 10th C and let's see their projects.
Hi, it's me Hormat, and I'm here representing three models, and it's we have a box of sign in which we have different ratios of sign. जैसे at 90 sign का value will be 1, and then at 60 it will be root 3 by 2. It's it's like house of maths. यहाँ पे different shapes, it's like circle, cylinder and all. It's different. So in our surrounding, it's different shapes and all. And यहाँ पे it's like Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. And जो इन दोनों का area है of these squares, that will be equal to this bigger one. Thank you.
Great.
My name is Mohammad Mudassir. I am from 10C, and today I'll present the model of factorization of quadratic equations. So we'll take a big square whose area is x square with each side x, and we'll take 3 rectangles of area x. So we'll rearrange them. We'll also take 2 unit squares, and now we get this rectangle, and the area of rectangle is length into breadth. So its length is x into 2, x into 1 plus 1, and x plus 1. So we'll get the factors x plus 2 and x plus 1.
Thank you very much.
Hi, my name is Huzaifa. I have made this model of a clinometer. Clinometer was invented by William Abney in 1880.
It's an instrument that is used for measuring the heights or slopes, elevations and depression of an object. It can also be used to measure the slope of a specific terrain. This is also known as tilt meter. Tilt tree, हाँ.
Thank you very much.
Hello everyone, my name is Zara and I am from class 10C. I am representing the trigonometric ratios. So for example, you all can see the sine theta. The sine theta, the sine of 0 theta presents 0. The sine 30 presents 1 by 2. Similarly, cos theta. Cos 0 presents 1 and cos 30 presents under root 3 by 2. And similarly, all the trigonometric ratios have different values.
So we are currently standing outside class 10th E. Please showcase your project.
Hello. So I have made a square table in which we can see the squares of numbers from 1 to 17. So like this, 2 square is equal to 4, 3 square is equal to 9, 4 square is equal to 16. It's a very easy to use tool and you can use it anytime.
Thank you very much.
So this here is a clinometer. We can use it to measure the angle of depression. Angle of depression is if you are standing on a point and you are looking down. The angle from which you are looking down is known as the angle of depression. So let's just, if we move this down, suppose we are looking from this angle, this thread shows us the angle which we are looking down. Suppose this is 110 degrees, that means this angle from downside is 110 degrees.
This is the clinometer and this shows the angle of elevation, and when we use the 90 90 degree downwards, and this shows the upwards.
This is a volume and total surface area spin wheel. In this, you have to just spin the wheel, and you will find the respective volume and total surface or total surface area of the object. For example, the cube shape is here, its volume and its total surface area. We have cuboid, we have cylinder, we have cone, we have sphere, and we have hemisphere.
So we are currently standing outside class 10 F, and let's see what they've got for us.
So this is our model for today. It's Clinometer, and it's basically used to measure height of major heights like mountains and Mount Everest and K2. So how does this basically work? We have the distance between the object and the meter known, and also the height at which the meter is elevated. So after that, we'll first look from the pipe to the top of the height. So from when we look at from here, the angle will be known, which will be vertically opposite to this, so they will be equal. So then a triangle will be formed in which the angle is known. The angle is known as well as the base of the triangle is known. So using the trigonometric ratio, we'll be able to find the height of the triangle and the base that was already known. We'll add the two distances, we'll be able to find the total distance of the wall.
Thank you very much.
What we have here is a model of Pythagoras theorem, which is showing that p square plus b square is equal to h square. The area of this square and the area of this square combine to form the area of this square. All the things in this square and this square combine to go into this square. This proves one of the most important theorems, p square plus b square is equal to h.
This is a model of distance formula, and distance formula is used to measure distance between 2 points on a Cartesian plane. Here we have point A and point B. These its coordinates are x1 and y1, and these are x2 and y2. The distance AC distance here is denoted by x2 minus x1, and the BC distance here denoted by y2 minus y1. Now this makes a right angle triangle. So by Pythagoras theorem, AB square is equal to AC square plus BC square. AC square is equal to x2 minus x1 ka whole square, and BC square is equal to y2 minus y1 ka whole square. We remove the root, we remove the square from this side, and it becomes root to this side. So this gives us the distance formula.
So this is a working model showing that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining circle. So for example, this is 40 degrees, so this angle should be 20 degrees. That's right, so this is
nice.
So this is a polyhedron. It's made with a combination of several triangles. It is basically a strong engineering structure. It is made using these papers, and it's tied with the help of these strings.
So my model is on the sine theta value of different angles, like sine 60 degree, and that's sine 45 degree, that's and sine 30 degree, that is equal to 1 by 2.
So we are currently standing outside class 10G, and let's see what they've got for us.
Basically, this is a Clinometer. In this device, we use the tan ratio. First of all, calculate the height of a really tall building. Now, if I have a really tall building, I'll point this towards the top. If you want it, if it's really tall, you can use a laser, for example, and we'll calculate the angle which will be formed right here. Then we'll measure the base, and then using the tan ratio, we'll be able to get the height.
So we are currently standing outside class 10H, and let's see what they have got for us.
So basically, we have prepared diagrams representing Fibonacci sequence and the Clinometer. First, we have the Fibonacci sequence. Fibonacci sequence was a mathematical concept that was given by Mr. Fibonacci, a scientist of that time, a mathematician of that time. He believed that the successor number is the sum of two predecessor numbers, and it is evident throughout the nature. And Nashna will elucidate more regarding that.
So talking about the Fibonacci sequence, as you can see here, this is a spiral galaxy.
if I'll tell you a very interesting fact, it is that Fibonacci sequence is present everywhere in the nature. Everything is based upon the Fibonacci sequence. Everything follows Fibonacci sequence. For example, the spiral galaxies, we have everything. Even your face ratio is based upon the Fibonacci sequence. Now, what is Fibonacci sequence? Fibonacci sequence is that where we get each number by adding the sum of the preceding numbers. For example, the simplest of Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, and so on. So it has wide number of applications. It is a debatable topic still today. Like for example, your pine cones, everything is all based upon the Fibonacci sequence.
Next, we have a model that was given by Mudassir. He is not currently present with us. So this model has the main show of a clinometer. This represents the angle of elevation in some cases. So it's a mathematical apparatus that is used by mathematicians to do professional work in this field. So I hope that you enjoyed and were able to rivet your experience at class 10th H. So yeah, thank you.
So we are currently standing outside class 10th I, and let's take a look at their projects.
So a very good morning to everyone and all present here. I'm Ibrahim from class 10I. So today I'm going to explain the working of a clinometer. These clinometers are generally used for measuring the height of other objects using simple trigonometric ratios. Imagining that this is a triangle. Let's say we can first let's try to measure the height of this guy. So here. So first we need to find the angle of elevation. Once we have the angle of elevation and the distance between you and the object, or the observer and the object, you can easily find the other sides of the triangle. These are the solid shapes. This is the cube, this is the cuboid, and this is the cylinder, and this is cone. You can also see the formulas of these encrypted on this. And this right here is a model of coordinate geometry. As you know, every coordinate has 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And right here we have the properties are written. That is for quadrant 1 it goes like for the value of x it is positive, and for the value of y it is also positive. In quadrant 2, the value of x is negative and the value of y is positive. For quadrant 3, the value of x is negative and the value of y is also negative. For quadrant 4, the value of x is positive and the value of y is negative.
Clinometer. So you may have come across other clinometers till now, but this one is a different one, quite different, because it will give accurate measurements. So I didn't make it myself. First of all, let's give the credit. So Firdaus sir as well as Mutahar, another guy from 10G, has made this clinometer along with me. So this is used to measure the angle of depression or the angle of elevation in any fort, and it's used to find the height of any building using the angle of elevation or the angle of depression. And we use simple trigonometric ratios like tan and cot to find the angle of elevation and depression. So how we use this, I'm going to show you that. So actually we need 2 lasers for using this, but unfortunately we only have one right now. So one of the lasers is aimed at the top of the building, like I will show you right now. One of the lasers is aimed at the top of the building, and the other one is used as aimed at the base of the building. So we'll be able to find the angle. When we find the angle, all we need to do is to find the base. Then we can easily use the operation of tan and find the angle of and find the height of the building without the use of any scale or a measuring tape. So this is what we have made, and it's called a clinometer.
We have got one more project from class 10th A. Let's take a look at it.
Here is a clinometer, and it is used to find the height of an object. All you have to do is point this tube towards the top of the object, and with that we can find here an angle forming. This is known as the angle of elevation, and in this case it is 60 degrees. With that, we can easily find the height of an object.
So currently we have the mathematics coordinator, Mr. GM Malik, and let's have a word with him about the exhibition.
This is very good for the students to conduct a mathematics exhibition, because we want to correlate the mathematics with other disciplines. Like we want to correlate mathematics with music, art, and other. In class 10th we have a trigonometry, and students mostly say what are the main uses of this trigonometry. Today the students had make himself the models of clinometer. The clinometer we use how to find the heights of the tall buildings, mountains, and some students made the model of Pythagoras theorem. So students enjoyed very lot. The reason behind the mathematics exhibition was to remove the math phobia among the all students. However, this thank God mathematics exhibition comes to be very successful. I am very thankful to my students. They enjoyed very lot, and hope I will do more and more exhibitions in future. Thank you.
Currently, we have the social sciences coordinator, Mr. Shaukat, with us, and let's hear his opinion about the maths exhibition.
These kind of exhibitions are very crucial, especially they bring about clarity of concepts, spirit of research, inquiry, and teamwork and hard work. I think this also brings about clarity of concepts with kinesthetic and interdisciplinary learning.
So we have currently Mr. Parvez from mathematics faculty, and let's hear his opinion on the exhibition.
Thank you very much. Today's day is very important as we have organized an event, that's exhibition of the mathematics here, where the different students, they showed their innovative ideas, and we have worked on here that to give the abstract ideas the concrete idea so that the children can learn practically. And this day is very important, and more such events should be organized by the school because they are enjoying the practical way of learning all the mathematics. And I think the practical way of learning mathematics is encouraged every time, and it is an easy way of understanding mathematics concepts. And we hope in future more such events will be organized where our children can exhibit, where showcase their innovative ideas. Thank you.
So currently we have mathematics teacher Miss Sakina with us, and let's hear her thoughts about the mathematics exhibition.
Good morning. We had mathematics exhibition today organized by mathematics faculty in secondary wing. We tried to give examples of various demonstrations and projects where mathematics is used in day-to-day lives. We are hopeful that in future we may receive such opportunities from school again and again, so that we will show students how mathematics is helpful in nature and how it is manifested in nature, so that students may pursue this subject as their subject of interest, because no science is complete without the touch of mathematics.
Currently we have the prefects body with us, and let's hear their words about the maths exhibition.
I am Zubia Rashid, I'm from 9B, and I have with me Suhaib and Aino. They're both seniors. We are the managing body of 9th and 10th. We've been managing the entire 9th and 10th for the last 6 months, and we are the prefects from this building. Our duties mainly consist of managing the students, managing the disciplinary actions and the behavior of the entire building. It's been pretty rough, and the recognition has been pretty difficult to get, but I believe the teachers have been very helpful. Today's exhibition was managed by us. It was managed by the teachers. The teachers gave us instructions on how to manage this thing. The last exhibition was also the same, conducted in the same way. Well, we believe that the entire student council has been working very hard. The teachers have been working very hard, cooperating with us a lot. We've learned a lot, and that's pretty much it. Thank you very much.
So this exhibition was wonderful, energetic, and enthusiastic. I learned a lot of new things, and I hope that you must have also learned a lot of new things. Everyone was so happy here, and there was fresh air all around the campus. So until next time, see you soon.